Hello, do you like plants? Do you have a lot of plants at home? I have some. Who looks after them when we're home for a long time? New technologies came to help us. Smart devices make our life easy. And I want to introduce one more such device, plant watering machine. All devices must have a name, so I called it Smart Rain. Let me introduce Smart Rain system. Every plant has different watering requirements. This device allows organizing the watering process, taking into consideration these requirements and environment conditions. It continuously monitors ground moisture. It makes decision to water plant if moisture value is less than required. Let's have a look at schematic diagram. Smart Rain system has a main controller based on Tahoe 2 development board with installed .NET Micro framework. It has touch screen to interact with the user. It has peripheral board what connects sensors and water pump with main controller. Very often we have plants on opposite sides of house. XB wireless communication modules allow us to connect remote sensor to main microcontroller and organize monitoring independently where we are located. The main controller sends messages about current moisture and other events to the server, and being out of door, it can get report in form of diagram. Let's have a detailed look at each part of the system. Using Tahoe 2 with .NET Micro framework is the best choice for this project. C# language allows to program very easily. Big touch screen and Windows Presentation Foundation allow us to build rich and useful user interface. This board has a wide range of communication interfaces. I use inter-integrated circuit bus to connect a peripheral board to main microcontroller. The peripheral board has 4-channel analog digital converter, what converts analog signal from moisture sensor. I use only one local sensor at this prototype, but the quantity can be expanded easily. To measure moisture, I use a scheme with direct current generator. I measure voltage drop on the sensor at a constant current. It is proportional to ground resistance, and finally, it is inverse proportional to moisture value. The peripheral board also has input-output port expander to connect relay driver of the water pump and to read the status of the water level sensor. The port expander is also connected to microcontroller via inter-integrated circuit bus. The main feature of Tahoe 2 board is a socket for XB communication module. The first XB module is installed on the development board. Water pump, moisture sensor, and water level sensor are connected to the second XB module. I use analog to digital conversion facility of XB module to convert analog signal to digital code. Remote XB module is configured to send converted value and sensor status to the main controller every second. It also receives commands to switch water pump on. It works unassisted, without any additional microcontroller. Small peripheral board is used to connect above mentioned devices to the XB module. There are water tank, water level sensor, pump, hose, and sprayer in the system. Sprayer is installed over the ground in the flower pot. The pins of moisture sensor are put in the ground. Let's talk about software. After power is on, the main menu appears. You can make navigation over all menus by touching to the screen or using buttons. At first, you should set up which kind of plant you use on every place. There is a small plant catalog installed on the device. It helps you find information about every plant you have. It has a name and picture of the plant, watering requirements, and lighting preferences. If your plant is not in the list, you can choose general information for the plant with poor, normal, or rich watering requirements. I am finding information about plant. I've connected to the first sensor and to the third sensor. As I mentioned before, you can use touching to the screen or buttons for navigation. Go back to main menu. Next is a monitoring window. The monitoring window shows current and required moisture for each plant. The first place is monitored by local moisture sensor, and the third one by remote sensor connected through X-beam modules. The twin gauge shows moisture value. The light blue gauge conforms to the required moisture value, and the dark blue gauge conforms to the current value. After several measurements, the controller makes decision whether monitored plant is required to be watered or not. If decision is positive, the controller turns water pump on and shows the animated rain picture during all watering process. Afterward, the controller forbids the next watering with plant for 5 minutes, allowing water to get deeply into the ground. The similar raining process takes place with remote plant, but in this case commands are sensed with the use of wireless X-beam modules. If I want, I can start manual raining process by touching to the picture of the plant. The main controller is connected to the network. At the watering point, and every hour, the controller sends report to the server. I have a web service installed on the server. It is built using Windows Communication Foundation. All messages are saved on the server and can be used by website to build user reports. When you are out of home, you can connect to the website and request daily, weekly, and monthly reports for each plant. The line shows moisture value. The diamond shows the watering points. The yellow diamond shows automatic watering point, the red one manual watering point. This useful device will make our life easy. It will allow us to look after indoor plants better. I believe that in the future such devices will be almost in each house as we have today coffee machines or microwaves. New technology came to help us. Smart devices are expanding their fields of use, and .NET Micro Framework will be foundation for the majority of such devices, because it allows building advanced software for embedded world fast and easy. Using smart devices in the future, I hope we can even come to solutions like this.